We're going to carry out a test now to confirm the integrity of a protective bonding conductor. Obviously this is a dead test and we're going to have to disconnect the bonding to carry out the test properly. So first thing I need to do is isolate the installation, lock it off and make sure I've put the proper labels and locks on so that it's entirely safe. I then need to disconnect the bonding conductor which I'm going to test. Because this bonding conductor could be quite a long conductor, it's going to be what we call a long lead test. To carry out a long lead test, obviously I need a long lead, or I can use a long piece of cable, but it is much better to use the right type of equipment if you possibly can. The problem with this long lead, of course, is that it's going to have a resistance of its own. So for this test, I need to zero the leads, taking into account the resistance of this lead, okay? So what I do is I join the two ends together, the crocodile clips together, having plugged one end of the lead into the test meter. The important thing when you're zeroing leads is to ensure that you get the crocodile clips connected round the right way. If we look at a crocodile clip, we can see that this is a solid connection through there, whereas the jewels on this side are on a spring. We need to make sure that when we connect them together, we get the two solid connections touching each other. It might sound silly, but actually, we're measuring very low resistances here. Once I've done that, I set the tester to ohms, let the machine settle, then I push the button and we can see that I've now zeroed the leads. So any resistance value that I measure now will subtract the value of this lead. Of course, another way we could do it is to measure the resistance of the lead, write it down, take a reading, and then subtract the resistance from this lead at the end of the job. Okay, so we need now to measure from end to end. The value which we must be below, as far as guidance note 3 tells us, is 0.05 ohms. Can create a slight problem because guidance note 3 also tells us that these instruments have to be accurate between 0.2 and 2 ohms. So we're measuring something that's very, very low. Some of these instruments really aren't that accurate. This one's okay, but not all of them are. So a good measurement, really, a good way of measuring it is in length. For a 10mm bonding conductor, up to about 25 metres would be okay. If you get above 25 metres, you should really be looking at a 16mm bonding conductor. But we'll carry out the test anyway. First thing I need to do then, of course, is connect the end of my green lead to the disconnected bonding conductor, and this is bonding the gas, and then I need to go off and find the gas meter and do another test at the gas meter. So now we're at the gas meter, just going to carry out the final part of the check, and of course that's to measure the resistance of the main or the protective bonding conductor. Whenever I do this test, I prefer to use a connection on the pipe work rather than the clamp, because what that's doing me now is telling me that the integrity of the clamp is very good. There's a good joint between the clamp and the pipe. If there was dirt or corrosion underneath it, the resistance would probably be quite high. So you can see now I've got a reading of 0.02 ohms, perfectly acceptable for this installation. As I said, the value that we should be thinking of is 0.05, so this is quite low. One other good thing, which is a bit of a tip, sometimes as electricians we're not sure which side to connect the bonding conductor. If you look on the top of a gas meter, there's generally a chevron or an arrow. It's not really there to help electricians, but it can be. If you connect your bonding conductor on the side that the arrow is pointing to, you're never going to be wrong. So, and also, of course, we need to make sure that the clamp is before the first joint in the pipe.